Welcome back, Math 20-2. Today we're looking at confidence intervals and your margin of error. So we're still looking at probability statistics, but a lot of times when we take a statistic and the population is too big, or maybe we don't have the time to cover the whole population, we take a sample. So the mean of a population, what are the odds that it's going to be, or what is the probability that it's going to be exactly the same as the mean of the sample? The chances are they're not going to be exactly, they're going to be off slightly. And how much they're off by, that is our confidence interval. So if I said, for example, we're going to use a math class right now. Let's say there's 800 math students in this school. And I have a math class of, let's say, 30 students. Now I'm going to say the mean of my class is 70%. Now, does that mean the mean of every class, the mean of all math students is the mean of the whole population of math students is 70%? No, but it could help us figure out that most of them are probably within 70%. So what we do for this now is we're going to use something called confidence. All right? So we have confidence intervals, and that is our confidence that our mean, the actual population mean, lies within this much and this much, and it's based off of our sample space. An example would be, so I said 70% is my mean for my class, right? And then I said, well, I could be fairly confident, not 100% confident, that the school population, the math mean for all the math students, if we took all of them, the population is between 65 and 75. All right? So it's between 65 and 75. That is my interval. Okay, so it's my confidence interval is between 65 and 75. And I could be fairly confident on that. Now, I could be extremely confident if I said my range is between, the average in the school will be, the mean is somewhere in between 60% and 80% for all math students. Well, because mine's 70, so I'm giving myself plus 10% and minus 10%. So my confidence intervals is plus or minus 10. So my margin of error is plus or minus 10%, or 10 points on the percent. That's a huge amount. So I could be extremely confident that my mean will come in between there. Here's a little example here. It says, what if the range of values is between 63 and 72? What is the interval? Well, the difference between this is 9, and then we're going to divide by 2. And if we divide by 2, we're going to end up getting 4.5. So the interval, the margin of error is 4.5. So that is what we're looking at when we're saying margin of error, confidence interval, and then the next one would be confidence level. So my confidence level normally increases depending on a couple of things. One would be depending on the amount of how big my sample size is. If my sample size is most of the population, I'm going to be pretty confident in my students. For instance, if my class size of 800 students had 250 students I taught, right, math, and my mean for all of those was 70%, well then I could be pretty confident that the mean for math is 70%. I would say even 5% above the 65 to 75, I'm going to be very confident on that because I have a huge population of them, a sample being used. Whereas if I'm only using 50 students compared to 250, well then I better broaden my interval, okay? I better broaden my confidence interval. So my confidence level is the percentage as how confident I am that my mean is between a certain thing, okay? And my confidence interval is the interval between where the mean could rise, could land in. All right? So here we're going to look at now our example number 2. Or sorry, class example number 1. And it's looking at golf balls. So it says the mean mass of golf balls produced at our factory is 45.6 grams, okay? And plus or minus 0.3 grams. So determine the confidence interval. So for this first one, we just want to determine the confidence interval, or sorry, the confidence level. So if we want to determine the confidence level, well, it says it's true 19 out of 20 times. So that's 19 out of 20, which is 95%. So they're pretty confident that the mean that day will be Well, 45 point in between will be somewhere in the range of confidence intervals. What is the confidence interval? Well, it's plus or minus 0.3. So minus 0.3 is 45.3 at 2 all the way to, well, we go plus 0.3, 45.9. So we have 95% chance that the mean that day of golf balls is in between there. Okay? So what is the margin of error for this? Well, my margin of error is 0.3. We're either going up or down 0.3 grams. Okay? Next one says, is it likely that the mean mass of golf balls produced at this factory is 45.1 grams? Well, the average 45.1. 45.1 isn't in here, is it? It's too low. It's somewhere over here. And it's 95% of them are in there. So no, it is not likely. There's only a 5% chance that that happens. So that's not likely at all. Next it says, is it possible that a golf ball could be 45.1? Well, yeah, it's possible. There's a 5% chance. So yes, it is possible because it's not 100%. In between here is not 100% chance. So yes, there is a slight chance. Okay? There we go. So the next part here, it just explores certain things, okay? So it's going by an election, and we have different companies are saying who's winning and why, and what their margin of error is, and what they think which way the vote will go. So we look at this, the columns for the number of sample space and the margin of error. How does the sample space affect the margin of error? So if we look at the sample space here, and the margin of error. How does the sample space affect it? Well, the bigger the sample space, the smaller the larger margin of error. That makes sense. Think of my beginning example. If I said I was doing 250% of the students, my margin of error should be lower, right? My margin of error should be lower. I could lower my margin of error to have a good confidence. If I only had 50 students, well, I need a bigger margin of error because it's such a small sample space of all the students. So my margin of error should be bigger to get a higher confidence interval. Okay? So the next part here says, for each of the following firms, calculate the 95% interval for the percentage of Canadian voters who would vote in the Democratic Party. So the 95% interval, this here is their 95% interval of the Democratic. So for the Democratic, we go from 30 for this company here. We have 30 plus or minus, well, that's going to give me, if we subtract, 26.9 all the way to 33.1. Let's look at Angus Reid. Well, theirs is plus or minus 2.2. So that's going to be, we could be 30.8 all the way to 35.2. Okay? And we keep on doing that, all right? Nanos research is going to be, we have 27.6 to 33.6. And then the last one is Echos. Echos is 29.4 all the way to 33.0. Okay? So those are our 95% confidence intervals. So now here they continue and they say they are going to they're going to overlap, see the the first one, we already did this confidence interval with the NDP, and we want to compare it to the confidence interval for conservatives. These are just two parties in Canada. So what is my conservative? It's 35, and it's plus 3.1. So what am I going to get? So what am I going to get? I'm going to end up getting 31.9 all the way to 38.1%. Okay? And we found out from before in our last table this was 26.9 to 33.1%. 3.1. So remember, we still have to go back to here and look. We know it's 30, and we need plus or minus 3.1. Next one, we're going to have, we're doing conservatives, 35 plus or minus 3.1. Next one's 37 plus or minus 2.2. Next one after that is 37 again, plus or minus 3. Then we're at 33.9, and we're plus or minus 1.8. And what we're going to end up getting is, we end up getting 34.8 all the way to 39.2. Here is 30.8 all the way to 35.2. Here's going to be 34.0. Okay, so that's what our thing goes. Now, this part here says, in which of the polling firms is there no overlap? So which firm is there no overlap between the conservatives and NDP? Well, the only one is this nano. The max here is 33.6. The min here is 34. There's absolutely no overlap. So that's with the nanos. Now, what that means, if there's no overlap, with a 95% chance that we're confident that these guys are higher, that these guys, the conservatives, will beat the NDP in the election. Okay? Then it says the polling firm, which ones have overlap? Well, all the rest, these three here, have an overlap. So what does that mean? That means it's hard to tell who will win. Either or could really win the election because there is a bit of an overlap. Okay, so we cannot say with 95% who the voters will choose, either conservative or NDP. All right? So part D says, in which polls can 95% confidence intervals that the NDP will receive a higher percentage of vote than the Liberal Party? So then all you have to do is go back and find if it's a higher percentage of growth. We want to find everything where there's no overlap. Anytime there's no overlap, and between which firm, if there's no overlap, that means they will win. The one party will win. The higher party will win. Okay? Now right here, and you're 95% sure. The next one says, which of the polls say with 95% confidence, in which polls do we say 95% confidence that the Bloc Québécois will receive a higher percent of the vote than the Green Party? So the only ones where that happens is if there's an overlap. So if there's an overlap, we could say none of them. And if you do this quickly and you look, there's an overlap between confidence intervals like this, that means they will not be able to say, hey, someone, NDP, or sorry, Bloc Québécois or Green Party will win. Okay? So here we're going now look at example number 2. Just quickly get to this one. And this one's looking at a sample size. So it's looking at hockey pucks. Now the company makes hockey pucks and they know their mean. In a game, the hockey puck must be between this much weight. Alright? So they're making hockey pucks. They know not everyone's going to be the same. So they say their mean is between this and this. Okay? Where their mean mass is this. But that's where they want their mean mass. So then looking at this, it wants to know what is the confidence interval. Well, the confidence interval, if we read this question, well, they want their grams to be between there and there, is going to be between 166.7, a mean of 166.7, to 170.3. The next part says, state the margin of error the company is using. Well, their actual mean, they want to produce a mean of this, but they know their margin of They know that they're using this as their interval, so their margin of error is 0.3. That is their margin of error. And they're plus or minusing 0.3 grams. These are grams. Last one says, how many pucks should be weighed to ensure that the mean is between 0.6, 49 out of 50 times? Well, we look at this here, 49 out of 50 times. What is 49 divided by 50? That is 98%. So how many pucks should we use? 73. Well, if we only wanted 95, we'd only weigh 52, and that makes sense. The more pucks we weigh, the more confident our confidence interval will be. The more confident we will be correct. So we will have to use 73 pucks. We're going to have to weigh. Okay? Now D says, pucks which do not satisfy the league regulations can be used in practice. How many pucks should be weighed if the country wants to ensure the mean mass range between, the mean mass is this to this 9 out of 10 times. So that means 1 out of 10 of those pucks will be used in practices. Or 1 out of 10 of the mean days will be used in practices. So we go back and we have to find the 9 out of 10. And 9 out of 10 was, back here, 9 out of 10 is 90%, which is 36 pucks. We need 36 pucks. Okay? The next one says they need to weigh 36 pucks. The company, if the company is willing to accept a mean mass of this to this. So our mean mass is increasing. So they're accepting a bigger mean mass. Alright? So they're saying the confidence interval is between there and there. Would they need to test more or less pucks in order to attain the same confidence intervals? Well, if I expand my range of error, I don't have to test as many, so that's less. Right? It goes back to the students thing. When I have if I expanded, if I said I wanted between 80% and 60% the mean, well then I could only take 50 students to a sample. If I said I wanted between 65 and 75 the average, well then I'm going to take like more, like 250, okay? Does that make sense? So this means we need less pucks to weigh. Because we're not being as specific with our confidence interval. So we need less pucks. Okay? Last question is, use confidence intervals to interpret the following question. So in a recent survey at a Canadian high school, it says the average student spends 1.5 hours on internet, 1.7 per day physically fit, okay, or per day doing physical activity. Now, the results are considered to be accurate within 0.2 hours, 24 out of 25 times. So what does this mean? Well, first of all, 24 out of 25 times, that's going to be a 95% confidence level. Or sorry, 96% confidence level. If we divide that, we get 96% confidence. Okay? Now also, we know our margin of error is plus or minus 0.2. Okay? So we could say with 96% certainty, there's an I there, with 96% certainty that students will spend now 1.5 hours on the computer plus or minus 2, so 1.3 to 1.7 hours a day. On internet, and they will spend, well, 1.75 physically fit, so we have to add and subtract 1.2, and 1.55 to 1.75, or 1.95, have to add 0.2 to 0.75 hours a day physically active. Doing physical activity. Alright? So that is what they found, and it's 96% certainty that the average student will spend between this and this, the mean of them. So this much time on internet, this much time doing physical activity. Well, good luck on your assignment tomorrow. Make sure you come up with some good questions. I'm sure you have some, and I look forward to seeing you guys tomorrow as we work on questions together.